Hey guys, how's it going? Today we are going to be in our stoichiometry unit doing day 4 and talking about limiting reactants. I love this topic. I'm super excited. And yeah, let's just jump right in. Okay, so after today, you will hopefully be able to calculate the limiting reactant using two mass-to-mass calculations. And I say two, you're going to need to use two problems for each or two calculations for each of these problems. Be prepared to do some math. These ones require a little bit more math than the other problems. All right, so let's talk about this. Um, First of all, the limiting reactant, which we're going to abbreviate LR, is the reactant which runs out first and limits the amount of product that can be made. And in each of these problems, you're going to do two mass-to-mass calculations so that you can figure out, given a certain amount of each reactant, how much product can be produced with that much reactant. The limiting reactant is the one that yields the smaller amount of product. Okay, I'll say that again. The limiting reactant is the one that yields the smaller amount, the smallest number. Okay, so let's look at a real world example, and we're going to make some funfetti cupcakes. So our equation, if we were going to write this out, we're going to have a cupcake mix. We're going to have some eggs and some oil and produce some pan of cupcakes. All right. So let's say it takes one mix, 3 eggs, and 2 tablespoons of oil to produce one pan of cupcakes. So that is our chemical equation, right? That's our equation. Now let's say I go into my kitchen and I have 3 mixes of cupcakes, or 3 mixes, cupcake mixes. I have 15 eggs, and I have 8 tablespoons of oil. And I'm trying to figure out how many total pans of cupcakes I can make with that, so that I can produce the most cupcakes possible, right? So we're going to start off with our mixes. We have 3 mixes, and it takes, if we look at our ratio, it takes 1 mix to make 1 pan of cupcakes. So I'm going to put that in, 1 mix to 1 pan. Okay, so that means if I have 3 mixes, I can make 3 pans of cupcakes. Now let's look at the eggs. So I'm going to use the next ratio, 3 eggs to 1 pan of cupcakes, and I'll go ahead and put that in. 3 eggs to 1 pan of cupcakes. So with 15 eggs, I could essentially make 5 pans of cupcakes. Okay. And now I look at the oil, and it takes 2 tablespoons of oil to produce 1 pan of cupcakes. So 2 tablespoons of oil, 1 pan. So with that 8 tablespoons of oil, I could produce 4 pans of cupcakes. Now I can look at this and be like, all right, well, my mixes, there's only 3 pans. I can only make 3 pans because I only have 3 mixes. So this is what we would call the limiting reactant. So the mixes are the limiting reactant because they're used up first. All right, you would have excess eggs and oil, but the mixes are gone, and so then you can't make any more cupcakes. All right, so let's go ahead and relate this back to chemistry and how we would use it in chemistry. So here's our example. If you have 17.1 grams of potassium and it reacts with 14.3 grams of fluorine, which reactant is a limiting reactant, and what mass of potassium fluoride can theoretically be produced? All right, so we have to look at this and figure out with each one of these amounts, so with the 17.1 grams of potassium and with the 14.3 grams of fluorine, how much potassium fluoride are we going to get? So let's go ahead and write out our equation. The word equation is potassium plus fluorine reacts to form potassium fluoride. All right, we're going to write out a formula equation. So we've got 2K plus F2 reacts to form 2KF. Okay. All right, so we have our equation, and now we have two problems to do. First, we have to figure out with 17.1 grams of potassium how much potassium fluoride are going to be produced. And then we have a second problem where we figure out how much potassium fluoride will be produced with the 14.3 grams of fluorine. So again, with each of these, you're always going to start out with what you know. We know we were given 17.1 grams of potassium, so we are going to start with that. So let's go ahead and get that up here. All right, so we have 17.1 grams of potassium. All right, we need to use the molar mass to change our grams into moles, and the molar mass of potassium is 39.10. So go ahead and put that conversion factor in. We can cross off our grams of potassium. And now we need to use our mole ratio between potassium and potassium fluoride. And as you can see, it's a 2-to-2 ratio. So I'm going to go ahead and pop that in. 2 moles of potassium fluoride are produced for every 2 moles of potassium that are used. All right, and then I need to change my moles of potassium fluoride into grams of potassium fluoride. So go ahead and look to the right, and we're going to calculate our molar mass for potassium fluoride. So we have 39.10 as our molar mass of potassium and then 19 as our molar mass for fluorine. We add those together, so we have a molar mass of 58.10 grams. We go ahead and pop that in. We can cross off our moles of potassium fluoride, do the math, and we would get 25.4 grams of potassium fluoride if we start with 17.1 grams of potassium. Okay, we're not done. Okay, we've done the first part. All right, now we have to figure out, well, how much potassium fluoride will be produced with the 14.3 grams of fluorine. So we know the 14.3 grams of fluorine, so that's what we're going to start with. Again, we got to turn this into moles, so we use a molar mass. And remember, fluorine is a diatomic element, so we have to have 2 of those atoms. So that's 38 as the molar mass. All right. Then we look at our mole ratio of fluorine to potassium fluoride, and we can see it's 1 mole of fluorine for every 2 moles of potassium fluoride produced. So we're going to go ahead and put in that ratio next. Cross off our moles of fluorine, and now we can again grab that molar mass for the potassium fluoride to turn it into grams, and we get 43.7 grams of potassium fluoride. All right, so you can see you have to do 2 steps. Now we look at this and we're like, all right, which amount is smaller? Which amount is smaller? And as you can see, 25.4 is smaller than 43.7. Therefore, the limiting reactant is going to be potassium. When we only have 17.1 grams of potassium, the most we can produce is 22 or 25.4 grams of potassium fluoride. So the limiting reactant is potassium for this problem. All right, so really this isn't, you're not really doing anything new. It's just you have to do 2 things. So you have to do your mass to mass calculation twice to figure out how many grams of potassium fluoride will actually be produced. Potassium is the limiting reactant, and of course the 25.4 grams is what is going to be produced. All right, hopefully that made sense. If you have questions, please feel free to text me. I will Zoom individually with you if you need me to. There's lots of videos out there. Check out Khan Academy. Check out, just if you put in stoichiometry limiting reactants in YouTube, you will come up with a bunch of videos that will potentially help as well. Just a reminder, I posted this on the LMS wall, but I wanted to remind you we're going to have a quiz on Monday. We're going to Zoom, and you're going to actually take the quiz during our Zoom class. I will post it. I will be able to see when you log in and when you submit it, so that you guys are, it's going to be a little bit more like actually taking a quiz. We're going to review worksheets like lessons 1 through 4. Essentially, I want to be able to see that you know how to use a mole ratio, know how to go from volume, particles, and mass to moles and back and forth in those, and then being able to calculate a limiting reactant. So, all right, you guys, have a wonderful weekend.